Hi everyone, this is Miss Mazen here. Today we're talking about quadratics, specifically completing the square. This is from the MPM 2D, grade 10, academic math. Quadratic relations can be represented using three different equations: standard form, factored form, and vertex form. And these three equations, they're interchangeable. What does that mean? It means that you can change from one format to another. Let's have a look at the order. So we can go from vertex form to standard form and vice versa, and we can change from standard form to factored form and vice versa. Today, our focus will be on converting from vertex form to standard form and vice versa. So let's start with converting from vertex form to standard form. Now, in order to do this, we dig into the crates of our knowledge and recall everything we know about polynomial expressions. So that's FOIL, distributive properties, simplifying like terms, because essentially that's what we're doing here when we're given an equation in vertex form and we're asked to convert it into standard form. Here's a quick refresher. So the equation 2 bracket x plus 3 close bracket to the power of 2 plus 7 is in vertex form. First order of business is duplicating the bracket since it's to the power of 2. Then we FOIL, simplify the terms within the bracket, distribute the coefficient 2 to all the terms that are in the bracket, and finally, we simplify our constants 18 and 7, which add to 25. Our final equation is 2x squared plus 12x plus 25. All right, so let's do the reverse from standard form to vertex form. This is going to be new. Converting an equation in standard form into vertex form is also referred to as completing the square. Now, when you're given an equation in standard form, ax squared plus bx plus c equals 0, take note of your a value because there are two versions to completing the square. Either a is equal to 1 or a is greater than 1. And we'll go through what that means in a minute. So take it back just a little bit and ask yourself if you remember how to factor perfect square trinomials. That means that you get the same value using the product sum method. Here's an example. X squared plus 14x plus 49. Now using the product sum method, we need to find two numbers that add to 14 and the same two numbers multiplied to give us 49. Well, that's 7. 7 plus 7 equals 14. And 7 times 7 equals 49. So since we have two identical brackets, we can write it as one bracket to the power of 2. Now you'll need to keep this reminder really close at hand because we will use the exact same strategy when we're completing the square. Here are the steps to completing the square. Step number 1, bracket off the first two terms. Both of those terms should have variables. You're going to common factor by the value of a only if a does not equal 1. And also, we never common factor our variables. Step number 2, follow this one with precision. You will divide your second term that's in the bracket by 2 and square it. You're going to get something we call answer squared. And then you add answer squared and subtract answer squared all within your bracket. You started off step number 2 with 2 terms in your bracket. You end step number 2 with 4 terms in your bracket. Step number 3, evaluate for answer squared. Step number 4, remove the value with the negative sign to the outside of the bracket. I always say get rid of the negativity. But if you have a coefficient to your bracket, let's say if you had to common factor in step number 1, and you have a coefficient, you must multiply the negative value by the coefficient. Step number 5, you're going to simplify those constants. So the two terms that are now on the outside of the bracket, simplify them. And then you're going to factor the 3 terms that are left inside of your bracket. You're going to use the value after dividing the second term by 2. So you're going to use a value that you obtained from step number 2. And I'll show you how that works in our examples. And finally, step number 6, you will have two identical brackets that you will write as 1 to the power of 2 plus or minus your constant, and if there's a coefficient, you have that in there as well. That will be your final vertex form. Here we have example number 1, x squared plus 4x plus 3 equals 0, and this is in standard form, converting it over to vertex form by means of completing the square. Let's get it started. So step number 1, bracket off the first two terms. Both of those terms should have variables. So in this case, we're going to put brackets around x squared and 4x. Now our a value is 1, so we don't need to common factor, and remember, we never common factor our variables. Step number 2, so we're dividing the second term by 2 and squaring it. So that means 4 divided by 2 equals 2, and then 2 squared. We are going to add 2 squared and subtract 2 squared, all within the bracket here, to give us x squared plus 4x plus 2 squared minus 2 squared, close bracket, plus 3 equals 0. Step number 3, evaluate for your exponent. So that means we're going to evaluate for 2 squared. So we're going to rewrite our bracket as x squared plus 4x plus 4 minus 4, close bracket, plus 3 equals 0. Step number 4, get rid of that negativity. So we currently have plus 4 and minus 4 within our bracket, and as such, we're going to remove the one with the negative sign inside of the bracket and just place it right beside the positive 3. So our new equation will read bracket x squared plus 4x plus 4, close bracket, minus 4 plus 3 equals 0. Step number 5, first thing we do is simplify negative 4 and positive 3. That will give us a negative 1. And then we're going to need to factor. So we have a trinomial here that's inside of our bracket. X squared plus 4x plus 4. Now we need to find two numbers that add to 4 and two numbers that multiply to 4. Side note, it will always be this value here. After you divide your second term by 2, it will always be this value here. So our number is 2. 2 times 2 is 4, and 2 plus 2 is also 4, which is our b value. We rewrite our trinomial in factored form, and since our two brackets are identical, that leads us right into step number 6. We write our identical bracket to the power of 2. So y equals x plus 2 in brackets to the power of 2 minus 1. So looking at example number 2, that's negative 2x squared minus 4x minus 6 equals 0. Starting with step number 1, where we bracket off the first two terms, both of them with variables. Here we're going to put brackets around negative 2x squared and negative 4x. Now our a value is not 1. Our a value is negative 2, which means that we need to common factor the two terms that are within our bracket by negative 2. We are then left with negative 2 bracket x squared plus 2x, close bracket, minus 6 equals 0. Step number 2, we are dividing the second term by 2 and squaring it. So that means we divide 2 by 2, which equals 1, and then we do 1 squared. We're going to add 1 squared and subtract 1 squared, all within our bracket, to give us negative 2 as our coefficient, bracket x squared plus 2x plus 1 squared minus 1 squared, close bracket, minus 6 equals 0. Step number 3, we are evaluating for our exponent, which is 1 squared. So we're just going to rewrite our bracket as negative 2 bracket x squared plus 2x plus 1 minus 1, close bracket, minus 6 equals 0. Step number 4, get rid of the negative vibes. So that means we must remove -1 from our bracket. Now, since there's a coefficient to our bracket, we must multiply them. So that's -2 times -1 to give us +2, and then place that on the outside of the bracket just next to our -6. Step number 5. Simplify our constants. So that's -2 plus -6. That gives us -4. And then we look at the trinomial that we have within our bracket, ignoring all other terms. We're going to go back to step number 2 and pull the answer that we had after dividing our b value by 2, which is 1. We're going to check to see if that works for our product sum for the trinomial inside of our bracket. Now we need two numbers that add to 2 and multiply to 1. 1 plus 1 is 2, and 1 times 1 is also 1. So our magic number here is 1. We're going to rewrite our trinomial in factored form, and we get two identical brackets here, leading us right into step number 6, where we write those identical brackets as 1 to the power of 2. So my final equation is y equals -2 bracket x plus 1, close bracket, to the power of 2 minus 4. Example number 3 now. So it's 1/2 x squared plus 3x plus 5 equals 0. So first off, do not fear. Fractions don't mean that we follow a different process, but let's get into it and I'll show you how it's exactly like the previous example. Step number 1, bracket off the first two terms with variables, and that means it's 1/2 x squared and 3x will be in our bracket. Now our value for a is not 1, it's 1/2. So we need to common factor by 1/2. So 1/2 divided by 1/2 gives us 1. And 3 divided by 1/2 gives us 6. So our new equation will read 1/2 bracket x squared plus 6x, close bracket, plus 5 equals 0. Step number 2, divide the second term by 2 and square it. So that means our second term is now 6. 6 divided by 2 equals 3. And then we need to square 3 to the power of 2. Now within our bracket, we add 3 squared, we subtract 3 squared. Here's what our new equation looks like. 1/2 bracket x squared plus 6x plus 3 squared minus 3 squared, close bracket, plus 5 equals 0. Step number 3, evaluate for our exponent, in this case 3 squared. Our new equation will read 1/2 bracket x squared plus 6x plus 9 minus 9, close bracket, plus 5 equals 0. Step number 4, again we're going to get rid of that negativity. So we're removing -9, and on its way out, we're going to multiply it by 1/2 since that's the coefficient of our bracket. So here we have 1/2 bracket x squared plus 6x plus 9, close bracket, minus 4.5 plus 5 equals 0. Step number 5, we're going to simplify our constants, that's -4.5 and positive 5, and we'll get positive 0.5. And by now we're pretty comfortable with referring to step number 2, where we divided our b value by 2 and using that value to factor our trinomial in the bracket. We know that 3 plus 3 is going to give us 6, and 3 times 3 is going to give us 9. So 3 is definitely our magic number, and we go ahead and rewrite our trinomial in factored form. So it looks like 1/2 bracket x plus 3 and another bracket x plus 3 plus 0.5 equals 0. And if we wanted to just place that in vertex form, that's step number 6, we have our final equation as y equals 1/2 bracket x plus 3 to the power of 2 plus 0.5. Here are the skills to succeed. First, we need to verify if a is equal to 1 because that tells us which version of completing the square to use. And then you work in sections. Completing the square is kind of a big job, so working in sections makes it easier and ensures that you make less mistakes. Now, after that, you evaluate for the exponent before it leaves the bracket. That's super important because that can change your entire quadratic equation. And finally, remember what the vertex formula looks like in its original state without any values. And just like that, you've become a master of completing the square. Thanks for watching.